Hello and welcome everyone. I'm Tropin and today we talk about completion in Emacs. It's a huge topic. Completion in general is a huge topic, and one of the reasons why I decided to cover it is my own experience with completion engines in different text editors or development environments. Hello, hi there. My story probably started many years ago. At the time, I was using Vim and had quite hard time configuring completion for my programming environment. And later, I switched for different reasons to Emacs, and also had a lot of interesting issues, including the number of packages which provides completion, and moreover those packages was overly complicated and it was hard to know how they works, how they provide candidates and how to integrate with my programming environment and so on. Also, I had no idea how tab works. In some buffers it completed symbols, in some cases it indented the code and did a lot of different stuff which was completely unexpected. Hello Ivan, hello Mikhail, nice to see you here. And in addition to that, in Emacs I had not only completion which we expect from usual development environments in the form of overlay window with a few candidates near your point or cursor, but also some window which was appearing around my Emacs frame, which also was a completion, but a different type of completion. And in some cases, in addition to all the problems mentioned, it was quite sluggish and unusable, and my experience with it was quite unsatisfying. And I decided to learn a little about what happens under the hood. And after I figured out which components are involved in completion in Emacs, it became a little more clear why different packages exist, how they work, how they integrate with Emacs and with each other. And today I will try to share this knowledge with you, and probably will make your life easier with Emacs and with completion which works in Emacs. Okay, let's start from first type of completion which present in Emacs, and probably when you start working with bare Emacs without any configuration, you will see it in the form of something. For example, if you have some interactive action, you want to delete a file, you want to enter a comment, Emacs will make a prompt at the bottom of the frame. Here you can see mx prompt for comments, and after I type something, I can tap a tab button, and we'll see a list of completions in a separate completion buffer. And now I can continue typing a longer form of comment, or can type a different prefix and press tab again to see the list of candidates. To get one of those candidates, I can switch to completion buffer and pick one and click on it, and after that this function will be evaluated. It's a default user experience with bare Emacs without any additional configuration with default completion UI. And Minibuffer appears in many scenarios in Emacs usage when you're trying to open a file. And when you find a variable or function or something else, when you prompt for a question like yes or no and so on. And default behavior is manageable, but we can radically improve it. And first thing that we can do with it is to add annotation for completion candidates. Actually, in the past few years, Emacs radically improved many things related to completion, and one of these things is ability to provide annotation functions which can enrich your list of candidates with additional information about those candidates. As you saw here, when I type some prefix and press tab for completion, I get just a list of candidates, and for some of them we see key bindings. But if I enable a marginalia mode and type the same prefix and press tab, I will see the description of each function present here. The same happens for variables. One second. As you can see here, it's truncates lines. It's configurable, but I will temporarily make it easier to read for you. It helps a lot when you're looking for something and you don't have enough information about this subject. You can find it by using these annotations. Marginalia is a package not distributed with Emacs. It's external package you can install from Melpa, Elpa, and probably some other sources. Maybe it's not available on Melpa, maybe it's only on Elpa. I don't remember, but anyway, you can install quite easily. The documentation is also very good. The configuration is almost not needed for this package. You just install it, add to your load path, and use it by enabling marginalia mode. You can extend any list of candidates using those two keys and make annotation for almost any list of candidates. But marginalia does most of the work required by you. And in most cases, it's enough just to enable marginalia mode to get those annotations. After annotations, I would say the second thing which can improve Minibuffer completion experience is using a completion UI. The default completion UI has its strengths and downsides. I won't be comparing them too much with alternative completion UIs. I will just show you how other completion UIs can look like. For example, iComplete shows a list of candidates in the same line of the Minibuffer, and as I type, this list get updated. Sometimes it's quite useful. In some cases, we would like to see this list of candidates in not in one line, but in the list, in vertical list, like this. And I complete probably most important feature. It's a built-in package which shipped with Emacs, and you can use it with almost any modern Emacs just by enabling it. From my experience, it's not perfect, and it requires a lot of tweaks to get a sane experience with it, but it's a working solution, and I would advise you to try it at least and play with it. And if you're not satisfied with it, you can use some external packages. For example, I use Vertica, and Vertica is similar to iComplete vertical mod, but has a little better defaults, key bindings, and overall behavior. And here, completion UIs not only improve the visual style of your completion, but also improves user experience because it redefines key bindings and behavior, which can increase your productivity and to reduce the stress from pressing tab or from distracting windows which popping up at random places or which resizes unexpectedly and so on. There are some other packages which can provide you alternative UIs, but Vertica is quite simple and well integrated with Emacs built-in functionality. So for now I use it and quite satisfied with it. Another interesting package I tried is MCT by Protosilas, which does a nice trick. It uses completion buffers as default completion UI, but it updates it on the go when you type the completion prefix. Mikhail says that I complete freezes on the long list of candidates. Maybe I used it for some time, but don't remember problems with it. But it's possible that the implementation is suboptimal, and in this sense, Vertica is quite good in terms of performance. At least on my hardware, I didn't have any problems so far, any performance issues. There are some other alternatives like Selectrum and probably a few more, but I advise you to try which one suits better and keep it. After we changed the UI, we need to talk about the very generic topic is completion styles. It applies for every UI we have, and it's a mechanism, a part of Emacs, which can be utilized by UIs and can be not utilized by some UIs. And Vertica, iComplete, probably Selectrum, and few others relies on this functionality, and it's important to know about it. And also it can be used in some other places like completion at point UIs like Corfu. First of all, in Emacs manual we can find an information about completion styles, and basically the variable completion styles defines which completion styles will be used for completion. And most basic one, called basic, which matches the prefix, and we can actually try it out right now. I will just do a few changes to make this Emacs looks a little better, and let's try to configure the completion style. Completion styles basic. And before we will evaluate this thing, let's enable keycast to make you see what I do here. And let's try to type something like vertical mode. And as you see, I typed two things separated by space, and it showed a lot of candidates. And when I change completion styles to basic and type the same stuff, we have a different list of candidates, an empty list of candidates. This is because basic style works only and matches only the prefix. And when you move your cursor inside the middle of the word, it will match the prefix and will show you the candidates which matches this prefix. Going back to completion UIs, Mikhail mentions that iComplete allows to open default completion buffer, and it may be a nice functionality because having a separate real buffer that you can apply all your usual actions to is a nice feature. And interesting if it is a really useful in some workflows. I expect it to be useful in some cases, but in most cases you need just a simple list of candidates and pick the best suiting candidate as fast as possible. So creating a separate buffer is not necessary. Also, later I will tell about Embark package, which allows to create a separate buffer from the current list of candidates. Hello, star7. Let's go back to completion styles. Another completion style is substring. From the documentation, we can see how it works. For example, we will type the same word here, and after we place the cursor at the middle of the word, it matches the beginning of the word. Oops. But also it matches the end of the word. And there are a few more styles, for example flex, which allows to type you a few characters, and those characters will be matched in the same order, but with absolutely anything between them. For example, let's see how it works. For example, if we type vertic mod, all those things will be matched, but we also can type vet mod, and you will see you see that it still matches vertic mod, because you can treat it as a regular expression where between every character we have a wildcard, something like that. If you're familiar with regular expressions, flex mod takes the string and put between every character a wildcard which matches everything. This is how flex work, and the rest of the completion styles, the description for them you can find in the manual in a completion section, completion styles. And I have a link in the notes for the stream. I will publish those notes a little later, but the link will be somewhere where you can find it. Another package which adds more completion styles, called Orderless, and the documentation for it is quite good. And I will show how you can apply what provided by Orderless. But before that, we will talk about basics of Orderless. Orderless allows to type components separated by space, for example. It's configurable which character to use to separate components for filtering, but I prefer to use space as it's quite convenient. Dr. Ops says in IRC chat that Orderless always saves his day. Actually, it's quite powerful package, and almost in most cases I prefer to use Orderless as my primary completion style. Mikhail asks what completion styles do I use in my configuration. My primary completion style is Orderless. I have a fallback basic completion style for some cases. For example, for files, to make completion for Trump and some other things work correctly. And also I have partial completion for files to make it possible to do something like work GNU gigs. Oh, it doesn't work here. Okay. To make things like this works correctly. This is expansion of directories is done using partial completion, and I can press tab and it will substitute this short string to the full path, and I can continue completion from here, for example, using flex completion for th or initial completion to match to get less matches. I will talk about it a little later in Orderless example. What basically we can do with Orderless is type few things in any order, and each component will be matched against the candidates. And you can see here that first component matched with var, the second with mod, and the third with flat. And those components have different colors. And as you can see here, it doesn't matter in which order they appear here. This is why probably the package called Orderless, but it's more powerful than that. By default, the components can be the exact string, but also it can be a regular expression. For example, in this case, you see I used, instead of flat, a regular expression f dot asterisk t, which means match everything that has f and t in it. And to make it match only things that ends with t, I can use a special regular expression construction, which says that t should be at the end of the word. About regular expressions, you can consult the manual, and probably I have a link somewhere. Yep, it is in the Lisp manual. Let me see. Regular expression, syntax of regexp. And somewhere here, I hope you will find the information about the trick I did. Oh, right here, you can find the thing. Let me make a link for you. Regular expressions. Oops. Like this. Okay. In addition to that, to make orderless match things which contain spaces, for example, let me evaluate this package. Here you can see I used another package, I will talk about it later, to find a line in the buffer. And I want to reduce the number of matched lines by typing something is, and after is I expect a space. To match a space, I will use \space. It won't work by default. You need to configure orderless separator to handle \space as a space character, but you can use a built-in regular expression syntax for space, which is \s-, and after that some text here, or like this. You see how much works here. But I configured orderless something component separator value. Originally it was any number of spaces, but I changed it to orderless escapable split on space to make it possible to use \space for matching. This is basic functionality of orderless, and we can take a look at more advanced functionality of orderless. How to configure completion styles is described in the manual, but also in orderless package you can see a lot of useful information. And now to make advanced our completion styles to be a little more advanced, we will use style dispatchers functionality, and style dispatchers allows to change the type of matching for our components using some special functions. By default, orderless literal and orderless regexp used for matching components, but we can define a function which accepts 3 arguments: pattern, index, it's a place in the string. For example, when I type vertical mod, it will be the first component, ver, and mod will be the second component. And the index signals if it is the first component, use orderless initialism. If some other case, use the other style. In addition to changing of matching style from orderless regexp and orderless I don't remember the one, orderless literal, we can not only change the style of matching, but also can change the string we match against by some additional manipulations on the string. And why it's useful, I will show you a little later. Or we can see what is done here. Here, the function works in the following way. If our pattern is exactly one character, which is exclamation mark, it will use orderless literal with empty string, which basically does nothing. If our pattern contains a prefix, exclamation mark prefix, it will use orderless without literal style, which creates a regular expression which omits the pattern from the list of matches. I implemented similar functions in my configuration, but they use suffixes instead of prefixes and work in the following way. For example, if I type vertica and type exclamation mark, it will omit all the candidates which contains word vertica. Or for example, whoa, it doesn't work. Very unfortunate. Probably I did something wrong. But okay, let's not focus on this particular completion style. Let's take a look at the other one. For example, the initialism style can be triggered by adding a comma at the end of the pattern, and it will use every character and try to use it as the beginning of the word. And here you see it matches only candidates which contain O and M at the beginning of it. For example, I can find completion endpoint function by typing cap and comma at the end. Also, if I want to do an exact match, by default we remember that we have literal and regexp match, but if I want to use only literal match, I will add a equal sign at the end of the component. And what else we have? And also we have a flex match, which we discussed earlier. matches all the things looking like that the same thing I can achieve with regular expression, as you saw here. And this one. Those two components match the same candidates. As you can see, the number of candidates doesn't change if I remove one of those components. This is almost all you need about Orderless. And last thing that you need to know about completion styles is that we can use completion styles globally for all the Minibuffer completion which happens anywhere. And also we can use some particular completion styles for some specific completion categories. And here I override completion styles for project file and file. But we can do it for much more categories, but I don't have a need for this, so I redefine it only for project file and file, because it partial completion for files is more important than orderless, and the basic is required for Trump to work correctly. So I have styles for those categories redefined. Okay. We talked about separator for orderless. We talked about different dispatchers for orderless. And also, let's take as example CAPF. As you can see here, we match two candidate which contains the literal CAPF string. But if we use comma at the end, it will match completion at point functions. And if we use a tilde at the end, it will match every word which contains those characters in the same order. Every candidate, not word. Okay, I think that's it about completion styles. Let's go to another package which called consult, which provide and improves Minibuffer completion in some cases. Consult basically provides a helpers which allows to add functionality to built-in functions which uses Minibuffer completion, or which provide just a separate helper function which doesn't have analogs in built-in Emacs. The most important function for completion, for Minibuffer completion, called completing read, and it accepts a prompt, collection, and few other optional values. As you can see here, we have a prompt which is mx, and we have a collection, a list of comments. For other thing, for example, for eval, we have eval prompt. For find file, we have find file prompt, and different collections. Also, we can have a predicate which should be satisfied. We can require much, so we can't pick a candidate if we can't type arbitrary text in our Minibuffer, and it should match one of the candidates. We can specify initial input. We have specified default value. Default value differs from initial input. For example, here we have default value, but doesn't have initial input. But in some cases, I will show the case when we have initial input later, probably. Initial input is basically something that already typed for you in your mini buffer. History is a variable where the values which was used later stored for your completion, and inherit input method allows you to have the same input method as in your buffer. In the mini buffer you spawned using some comment. And this is a basic building block for mini buffer completion, but it can be substituted with other function which have the same signature and accept the same values. And console basically provides such functions with the same signature as completing read, and do completion for various scenarios, which we'll cover just in a few minutes. Valigo says, what's up, Epic Emaxer? Hope you're doing good, Andrew. Thank you, Valigo. I'm doing quite good and have a nice mood and also a nice audience. Okay, let's go back discussing consult. To describe most generic properties of consult, consult provides preview, it provides candidate grouping, it provides narrowing, and it provides line numbers. Line numbers for some functions, for example, for go to line. And I will show it how it looks in a second. Before that, we will talk about history. It shouldn't be here in console section, but when we discussed completing read, it was a history variable here, and we can see that when I type something here, for example, org mod, and after that Emacs Lisp mod, I can see the history, but by calling console history function, and we will see all the comments which was evaluated previously. And it will work not only for this thing, but also for go to line. For example, if I will go to visit, and after that I will go to buffer, I can call history and we'll see all those things. This is the first useful command from console that you can use to navigate the history of mini buffer completions. For example, you opened some file and you can see the list of the files you typed in find file dialog. It's quite useful, and in most cases can substitute the functionality of recently used files, for example, but only in some cases. In some cases, recent files are useful as well. The second thing which console provide is go to line, and I bind it to Alt-G prefix, as you can see here at the top of the window, and you see the prompt at the bottom, which asks for the line I want to go to, and it also shows the line numbers on the left. to make it easier to see which line corresponds to which number. And here I type 2, and here you see the preview. When I type something, it automatically previewed by consult. And to make this example more obvious, I will use the same function here. And when I type the line number, you see that the cursor changed, and we moved to the line I started to input. Okay, another function which I use quite often, consult line, and it allows to type some arbitrary text, my git log all, for example, and you see just a few matches, and I can jump between them, and it has preview as well. Talking about completion UIs, you can see that the Vertica displays the mini buffer at the bottom, but it's quite configurable. And in my default setup, for example, the same function go to line works differently, and the completion buffer will be moved to the window on the right. And when I type something here, I see all the candidates on the right, and it's a little more handy in my opinion and more useful. So some completions happens not at the bottom of my current frame, but at the other window. Guy Luinus asks, do I prefer this over Swiper Ivy? Yes, I prefer, and there are few reasons for that, but I will tell about them after we finish the next section. But before Vertica, I used Ivy, and before Ivy, I used Helm. So I went through the downshifting process from the Helm to the default completion, and from default completion to the Vertica. So I used a lot of things in Emacs and picked Vertica as my current completion UI for Minibuffer. Okay, this is how go to line works. Also, in addition to go to line, there are much more things like consult grep, consult imenu. Consult imenu is quite interesting thing because it demonstrates the difference between built-in imenu, which looks like this. Which allows to do the same thing, but much harder. And consult imenu have a preview. When I go through candidates, the other buffer shows the place where this candidate appears. Also, in addition to that, I can filter by the type using narrowing variables or functions. I type F and space and see only list of functions. Also, I have a hotkey to jump around those sections, but I don't use it usually. And you can see those sections are visually visible, like types, variables, and so on. And this consult menu I find more appealing than built-in menu and more easier to use. And this is one of the examples where consult provides alternative to built-in functionality. Sounds very familiar to your path. It's actually nice to see sometimes when the people having the same experience Yeah, it's especially cool when you read a book and you feel that character in this book have the same life situation as you, or some other person have the same experience with something. It's quite interesting feeling. Okay, to get more information about consult and all available functions, you can find in the documentation and the source code. In addition to what we saw here, it's important to talk about one more advanced feature, which I didn't mention here. Some functions, for example, consult grep, works asynchronously, which I'm not sure possible with completing read. But the list of candidates using grep or libgrep generated in the background, and after it's ready or part of it ready, the list of candidates get updated in Emacs. And also important thing about consult grep is that it uses hash for separating components which will be passed to the libgrep or grep command, and components which will be used to filter the resulting buffer without calling grep or libgrep again. And for example here, you can see that my git log all was passed to libgrep utility, and my git log was used to filter the matches that came from libgrep without recalculating the list of candidates. Okay, I think that most important things about consult is covered here. You can find a lot of useful functions. And I advise you to experiment with it by yourself. But we talked about preview, which useful in some cases and may be distracting in other cases, so you can toggle it using special customization mechanism for consult. We have grouping, which is also very useful for visually separating different type of entities in the list of candidates. We have narrowing, which allows to narrow to one group of candidates. We have some additional functionality like line numbers and synchronous work, and also ability to pass some part of input to the external process and some part of the input to internal Emacs mechanism for filtering candidates. Okay, and the last thing about Minibuffer completions is not about completions. It's about package called Embark, which allows to operate on thing at point or current completion candidate or currently matching completion candidates. And what I mean here can be demonstrated this way. For example, I want to see all the functions which starts with Vertica and ends with mod, and I want to make a separate buffer somewhere here to use it later. I can use Embark and call snapshot function, and you will see here at the right a buffer which contains all that function and the description for them. In addition to that, I can do the similar operation, but okay, let's called export, which provide additional information about those functions in special Embark export buffer, which can be used to read the documentation about each function, and quite handy in different scenarios. The same thing will work for files. For example, here I can export a list of files like this, or I can do the same but use export functionality, and it will open a direct buffer, which I can apply some basic direct functionality like key bindings and other stuff. Okay, this is a first thing that Embark can do. Take a list of candidates and do some operation on it. Also, we can do an action on particular candidate. For example, I can call Embark something describe symbol, which bind to h to get the documentation about this function. Or for example, in case of variable, I can use embark act equal to set the value of the variable, and can set orderless component separator to this value. And also I can use Embark not only from Minibuffer, but also from my usual buffer. For example, here I type, I use Embark act and type the same equal sign, and can set the value to something different. This is not directly related to completion, but can make some advanced use cases which can or cannot involve Minibuffer. And you're not restricted with built-in functionality of Embark. You can extend it, of course, and how to do it you can find in the documentation. I just need to mention this wonderful package, which sometimes really do a lot of useful things. For example, it simplifies tasks of removing files. I can pick a file from find file buffer and call delete on it using Embark act D hotkey for delete files, or I can use external program to open this file. And as you can see, this file opened in a separate Emacs instance, and so on. A lot of useful, cool workflows can be achieved with this simple package. Okay, we talked about Minibuffer completion, and it's already an hour. Oh, it's a lot. Now let's talk about in-buffer completion. It's actually what you expect from your integrated development environment. When you type something and the little pop-up or overlay appears and shows the candidates. But there are some other in-buffer completion things like wrf expand or snippet engines, and they work the way you probably expect Emacs functions or comments works. You type some text and call this comment using key binding or using extended command mx, and it's adjust the text under your point or under your cursor. Talking about wref expand, snippet engines, and some other functions which you bind to key or call directly in Emacs, they somehow find what is around your cursor and somehow modify it. But there also a more generic mechanism called completion at point. Completion at point is a function which gets as an input nothing. It finds what it decides to be around the point, and it can return a list of candidates or nil. In addition to list of candidates, it returns the position of currently matched thing, which it defines as a thing at point. To demonstrate, I will show the simple example. Using wref completion, let me launch another instance, and here I have, for example, buff, and I use wref expand, and it converts buff to the buffer. What basically wref expand does, it takes a word before the cursor and expands it with already mentioned word, in this case with buffer here. And if I use eval, it will complete it to evaluation. There are a lot of functions which do similar thing, but it's mostly ad hoc solutions. More generic solution is a completion at point function. Completion at point function usually not called directly, but called by another thing. For example, it can be triggered by completion at point function, which takes a list of completion at point functions and tries to apply them one by one until one of them will return a list of candidates. And when the list of candidates returned, it will use completion in region function to present this list of candidates. And when you pick one of those candidates, it will substitute the currently matched thing at point with this candidate. And here I can type, for example, eval, and use CAPF. Okay, let's use not CAPF, yes, let's use wref completion. Because we have only one match, it will automatically expand it. It is automatically expanded. But if we have less matches, for example, in this case we have only two matches, you can see that we provided with two completion candidates, and when I pick one of them, the sync at point gets substituted with this candidate. Very good. It is how completion in region function work. It takes a list of candidates, it takes a thing at point, and when the candidate selected, it substitutes thing at point with this candidate. But we didn't see completion at point functions yet. To demonstrate it, I will use Geeks closure project and will show an example on simple closure program. And let's see completion at point functions value. For now, it contains only one function, tax completion at point function, which don't do anything useful yet. So I will enable iglot. Iglot is LSP interface. Let's spawn another Emacs instance with slightly different configuration. We have the same value for this variable. We spawn LSP using iglot. And now, if we take a look at completion at point functions value, we will see that it changed to iglot completion at point. And if we try to type something here, I will be provided with a list of candidates. Which comes from different sources, from different namespaces. But I know that there's some other functions which doesn't come from LSP server, but I want to see them in completion. And I know that there's a cider package which provides those completions. And now I start another process, and this process injects another completion at point function in this variable. And now when I type the same prefix, I get different results which come from different completion at point function. And also, as you can see here, I don't see the result which was previously proposed by iglot. The reason for this probably because cider completed point doesn't return nil when there is no candidates. That is why completion at point functions don't fall back to iglot. And to work around this issue, we will use this line, which says that I will create a CAPF by combining cider completion at point and iglot completion at point functions, and we'll set completion at point functions to this super CAPF. And let's see at the value of this variable. And as you can see here, now it's just some function without a name. But now when I type nd, it provides a list of candidates. But if I type another, it provides another long variable candidate, which was missing before. This way we provided an ability to combine different completion at point functions. But in addition to that, we can do another trick: set local completion at point functions to list keep file, for example, or keep the ref of file. Let's use file. Oops. Now we added cape file here, and when I will type something like /, we will see a list of files here, which is quite cool. So we now have completion for files, but also we still have a completion for functions and other stuff for our program. This way, providing different completion endpoint functions and adding them to completion endpoint functions variable, we can see different results. And also we can change completion in region function to present a list of candidates and the behavior used for previewing or substituting the single point. For example, if I disable Corfu mode and will type another and will type and you will see a list of candidates appeared in Minibuffer instead of this overlay window. This happens because currently completion in region function is equal to Corfu, and when I type end, you can see the list of candidates presented in the overlay UI provided by Corfu package. But when I disable Corfu mode, the variable of this function changed. This function basically defined in my configuration, and it basically says if vertical mode is available, use completion in region, consult completion in region function, which looks as you can expect it. Completion. Oh, probably it's not possible to call this function interactively. But you see the list of completion candidates appears in Minibuffer instead of overlay window. And if I disable vertical mode, it will fall back to default completion UI, and it will look like this. So completion region function controls how your completion candidates will appear, and you can use console to show the list of items in your Minibuffer, and you can use Corfu to show the list of candidates in overlay window. As you probably noticed, when I type end, the overlay window automatically pops up. It because Corfu after is set to true. This is variable controls the behavior of Corfu. But if I will set it to nil and will type and will enable and disable Corfu and will type end, now it not appears automatically, and actually it's much less distracting. But sometimes it's useful when this window appears automatically. But if I want to call it manually, I can just call completion at point function, bind to Control Alt I, which is the same as calling completion at point function. We already mentioned Corfu package, which I didn't mention here for some reason. We talked about more sources for completion at point. It's LSP server, CAPF, CAPE is just basically what consult is for Minibuffer. The CAPE is the same thing, but for in buffer completion. It's just a list of functions for completion at point, and also it is a number of helpers which allows to convert, for example, company backends to completion at point functions, or make one completion at point function from a few different, and so on. You can read more documentation, more about CAPE in the documentation. It's quite complete and interesting, and I advise you to do it. Okay, we talked about buffer completion, in buffer completion, and completion at point functions. We talked about using mini buffer completion with completion at point functions. We just utilize mini buffer capabilities for presenting list of candidates for completion at point functions. But also we can use completion at point inside mini buffer. For example, for building project, I use project compile, and this project compile asks me for target for make command, and when I start typing, you can see here it shows me a list of targets in my make file. So completion at point and Corfu can be used inside mini buffer completion. Another example is eval function. For example, when I type setq, let's do it here. Setq enable recursive mini buffer. It will show the overlay window with a list of candidates. Another trick that I didn't mention about Corfu, it can use orderless completion styles, and to input space I use alt space, and as you can see I don't exit from completion here, and in case I type just space I will leave the Corfu window. So it's a nice trick to know. Let's write it down. Orderless. Good. Now let's talk about alternatives. Probably many Emacs users know about Helm, Ivy, Company, Autocomplete, and all those packages. And actually, when you only start using Emacs, it can be kind of confusing to pick one which is good for you. I will explain a few differences between them. Let's start from the Helm. Helm is the mini buffer completion UI. It uses buffers for presenting list of candidates. It's quite huge. It's really complicated project which covers a lot of use cases, and it has a lot of functionality implemented in it. And this functionality implemented in a different way from what currently available in Emacs. And all the features I mentioned above, like completion at point functions, completion styles, completing read, and all other stuff are built in. But some of them also annotations, but some of them appeared relatively recently, just a few years ago. But Helm exists for much more time, and it implemented such functionality before it appeared in Emacs itself. So those things are not compatible with Emacs built-in things, and that is why in some cases you can see the conflicts, like the other completion UI may appear, or it can ignore some settings which set for completion and so on. And that is why I don't want to use Helm, because first of all, it's overly complicated and it's hard to maintain and reason about, debug and so on. It's doesn't integrate well with Emacs built-in completion capabilities, and it's of course clear why it doesn't do so, but it is a matter of fact right now. And also sometimes it can be a little sluggish, probably because it's quite complicated and the implementation is suboptimal and not optimized very well. Another project is Ivy, which is much lighter alternative to Helm, but has similar issues because Ivy appeared quite some time ago, where some functionality in Emacs about related to completion wasn't present. It re-implemented this functionality on its own in the way not compatible with Helm and not compatible with Emacs built-ins. So it's lighter, maybe more efficient in terms of performances than Helm, but still not suits my requirements, and that is why I don't use it. But before switching to Vertica and default completion UI, I used Ivy for quite a long time. There are some other packages that I don't use for similar reasons, like Ido, iCycles, and so on. And that's it about Minibuffer completion packages. The problem with other packages somehow similar to Helm and Ivy. Let's talk about completion at point packages like autocomplete and company. They both provide UIs like Corfu does, but by default they don't use completion at point functions and have some mechanism which built in a ad hoc manner, the same way as it done in Helm for Minibuffer completion. The same thing happens with company and autocomplete. Company is quite mature project and probably has a lot of functionality and integration with many other packages. And I don't use in most cases it for the same reason I don't use Helm. But there are reasons why you can prefer company to Corfu and to completion at point functions. Unfortunately, completion at point functions doesn't support asynchronous evaluation of the list of candidates, while company supports it. And this is a feature which make company probably useful and important, and this is the reason why you can prefer company to Corfu. Maybe there are some similar features in Helm and Ivy which not present in Vertica and built-in functionality, but I don't know about them and can't remember right now if something like this exists. But for company it's a quite clear benefit, but in most cases we can live without asynchronous fetching of candidates. So in many cases Corfu and completion endpoint functions will be enough. Okay, we talked a lot about completion styles, and let's talk about what we would like to see as an improvement to completion ecosystem. For me, it's just two things. First of all is orderless style, which matches called orderless without literal, which matches all the items not present in the literal string, for example, vertica and exclamation mark. For some reason it doesn't work in my setup right now, but the other problem with it is when I type org mod and I type org exclamation mark, I expect all the org entities to be removed from the list, but it won't work for orderless, and I would like to somehow work around it. I know the reasons why it happens, but I would like to have an ability to remove some candidates from the list. It can be done in a different ways, but let's discuss it later. Just my nice to have feature request. And another thing is asynchronous completion endpoint functions, which probably should be implemented in Emacs itself and later extended to CAPF and Corfu packages. And after this thing is implemented, probably company won't be really needed. I mean that Corfu and completion endpoint functions will be on the same level of functionality as company. And as a conclusion, let's repeat the things that we discussed today, and we'll start from most important thing you need to remember about the two primary types of completion. It's in buffer completion, which is done by either some functions like wref or snippet engine or something like that, or completion endpoint functions. The Minibuffer completion, which can be improved by using Minibuffer completion UIs, and there are completion styles, which allows to sort list of candidates and filter out the things that you don't like. And those three things gives you a lot of power to get all the completion ecosystem works very nice in Emacs. There are trade-offs between advanced functionality like Company or Helm provides and simple and elegant implementations like Vertica, Corfu, and built-in Emacs capabilities. So it's up to you what you really need, very advanced functionality or slightly smaller scope but with much more elegant solution. I prefer the second one, and as I mentioned earlier and showed in the demo during today's stream, there are a few packages which creates a good ecosystem. Those packages works well with Emacs and integrates with each other and other packages quite good. They're simple, performant, and quite nice. And using those packages, I create and maintain RD Emacs, and have almost everything related to completion pre-configured and unified, and everything in Emacs behaves very consistently, and I quite like it. I think that's it for today. Thank you for your time. Thank you for coming, and make love and not war. See you in a bit.